All right, we'll just give everybody a couple more minutes to join. I'll introduce myself. Actually, I'm Rachel Schwam. I'm an associate professor in the Department of Human Ecology and do work on energy and society. I'm trained as a sociologist, for those of you who don't know me. And Kevin Keys is our graduate student admin who does a very good job of keeping everything moving. And up on kind of in front of you now, if you're looking at your screen, is our speaker series for the rest of this semester. We have Will Burns coming to talk about carbon dioxide removal for dealing with climate change. David Hughes, who's here at Rutgers and is an anthropologist, talking about renewable energies, and then Gabriel Chan talking about equitable community solar. So a great lineup kind of coming up, and I'll introduce now. We're very happy to have Dr. Jackie Berger. She's the president of and co-founder of APPRISE, and has over 25 years in efforts to kind of assess and evaluate and improve public programs. At APPRISE, she focuses on energy efficiency programs for low-income households, residential customers, and commercial and industrial customers, and energy affordability programs for low-income households. She's done numerous evaluation studies for a diversity of government agencies and uses a diverse kind of toolkit of quantitative and qualitative analysis. She has her PhD in economics from Princeton and her bachelor's of science in economics from MIT. And we're very happy to have her here today to talk to us about energy efficiency program evaluation. So welcome.
Thank you so much for that introduction. So I'll be talking about energy efficiency program evaluation today. A little bit of an overview of what I'll be talking about. I'll be spending a lot of the time talking about the different research activities that make up the evaluation studies that we do. Over the years, we've also learned what are the characteristics of energy efficiency programs that lead to higher energy savings. So I'll be talking about what we've learned. And then I'll also be discussing the non-energy impacts of energy efficiency program. What are the other benefits that result from these programs? Just to tell you a little bit about APPRISE. APPRISE is a nonprofit research institute. We're located in Princeton, New Jersey, but we do work around the country. David Carroll and I co-founded APPRISE in 2002 with the mission of analyzing data and information to assess and improve public programs. We focus on both energy efficiency and renewables, and also on energy affordability programs that help low-income households to afford their energy bills. We do work for the federal government, the Department of Energy and the Department of Health and Human Services, state government agencies around the country, utility companies, and also for nonprofit organizations. I want to talk a little bit about why energy efficiency is important. People get really excited about solar and wind, and they are exciting, but it's important to understand why energy efficiency should be taken care of first. One of the reasons is the cost of energy efficiency. If you look at this graph here, you can see that solar energy costs about 13 cents per kilowatt hour produced. This compares to energy efficiency, where it costs about 3 cents to save a kilowatt hour of energy. But remember that number because we'll be coming back to that later. Other benefits of energy efficiency include improving home comfort. So by installing the energy efficiency measures, we can reduce drafts, get humidity to the appropriate level, remove cold and hot rooms, and reduce noise problems. We also can have an impact on health and safety by eliminating mold, improving air quality, taking care of carbon monoxide issues, getting rid of asbestos, and sealing up the home so pests can't come in. Now I'll move on to the evaluation research that we do here at APPRISE. Why is it important to evaluate? First, we want to measure the program impacts. And as I mentioned earlier, it's not only the impacts on energy usage, it's all of the other impacts that these programs can have. For example, having a positive impact on the local economy or reducing greenhouse gas emissions. We also want to think about what are the ways that we can improve our programs. Can we do a better job of meeting the goals of our programs? Can we improve the efficiency or effectiveness of our programs so we can produce the same outputs at a lower cost or provide greater benefits for the program participants? Can we do a better job of targeting the clients who we're aiming to serve or improve the satisfaction of our clients? Evaluation is also important because it's often required by the state, the Public Utility Commission, or another regulatory body. So here at APPRISE, we do a lot of different research activities that make up our evaluations within the impact evaluation and process evaluation areas. In addition to looking at the impacts on energy usage, we look at the impacts on the ability of low-income households to pay their energy bills, the impacts on the economy and the environment, impacts on health and safety. We also do surveys with program participants to get a better understanding about how they feel about the program and do a cost-benefit analysis. On the process evaluation side, we want to understand how the program is designed, and we conduct interviews with the program designers and the management team, how the program is implemented, and we can assess that by going on site and doing observations and inspections. And why is the program working or not Why is the program working or not working? And to understand that, we really need to bring together all of the evaluation data that we have. Impact analysis is the first area of our research that I'll talk about. So with the usage analysis, we want to know, were the expected energy saving results obtained? Are the energy measures cost effective? Should we change our measure selection procedures? Should we change our installation procedures? And do the contractors who are installing the measures need to be retrained? When we're conducting the analysis, our goal is to develop the most accurate estimate of how much energy is saved as a result of the program. So we weigh the costs and benefits of various approaches, and we consider what are the possible causes of mismeasurement or bias. And there are a few different options that we can choose from when doing the analysis. One is deemed savings, where we just say for each participant in the program, we're going to save a certain amount of electricity or natural gas. Another is to do projections, engineering estimates, or to use a TRM. And these are all using formulas to project how much energy you expect to save from the program based on the measures that are installed. And another option is an energy usage billing analysis, which I'll be going into in a lot of detail. So when we compare these different analysis approaches, they have costs and benefits in terms of the expense of the research method, the accuracy, and the attrition. Deemed savings that I described before can be preferred because it has the lowest cost, and you can include all of the participants in your analysis because the data requirements are nothing really. When we move on to engineering estimates and we have data on the measures that are installed, that has a slightly higher cost. It has a little bit of a higher accuracy. We lose a little bit of the participants sometimes if we don't have retrofit data. Now, when we move on to the billing analysis, that requires a lot more data. It has a higher cost, and we need to exclude participants if we don't have enough energy usage data before and after services were provided. Last, we can go on site and do metering. This is the most expensive. It provides the greatest accuracy, but because it's such an expensive technique, we can only do it for a small percentage of the program participants. It's also important to understand what we are measuring. When we do deem savings or use an engineering estimate, what we're measuring is what we expect the change to be just based on the measures that we install. And the problems with this approach is that we need to make a lot of assumptions. We have to decide what we think the installation quality is going to be. When we look at just the raw change in usage, the difference between the usage before the measures were installed and after the measures were installed, we are not taking account of the fact that weather can impact the change in usage as well as other factors. So therefore, we want to weather normalize. In order to take care of other factors, such as prices, economy, or market information, we also want to use a comparison group. I want to talk a little bit about projections. They're very commonly used, but they have a lot of disadvantages, and it's really important to understand that when you're doing projections, they may not turn out exactly as you planned. So sometimes we talk about projections as TRMs. TRMs are technical reference manuals, and these are manuals that lay out all of the formulas that are used in a program for projecting how much energy you're going to save. So these can be referred to as TRMs, engineering estimates, or projections. Basically, what they are equations that calculate the savings that result from measure installation compared to a baseline. So we have to ask, what is the baseline? The baseline can be the existing equipment, the equipment that was in the home before replacing it with the new equipment, or it can be the current code requirements, or what the standard equipment would be if you replace the equipment without an incentive from the program. What's commonly done is that they use the existing equipment for the remaining life in the existing equipment, and then the standard equipment as the baseline for the rest of the life of the new measure. So for example, if you're installing a new furnace and you think you had 2 years left of your old furnace, you compare the new high efficiency furnace to the old furnace in your house for the first 2 years. And then for the rest of the 13 years of that new furnace's measure life, you compare it to the current code. So a less energy efficient model, but more efficient than probably what you had previously in your home. One of the things that's important to consider is that low-income households might continue to use equipment well past the expected life. And therefore, when we're doing evaluation of low-income energy efficiency programs, we often compare the new equipment to what was in the home for the full life. Here are some examples of TRM calculations. If we just look at the first one, New Jersey 2018 TRM, the lighting savings is the difference between the wattage of the new LED that we install compared to the wattage of the incandescent bulb that was in the home previously. We multiply that by the hours that the lights are used, and we get the annual savings. However, the last term is an adjustment for the heating loss, because when you're installing higher efficient lighting, you're reducing the heat that's emitted from the lighting, and you're going to use more heating in the winter and less cooling in the summer as a result of the fact that you're emitting less heat. So that's an important interaction term to take care of. Here are some of the advantages and disadvantages of using TRMs. The main advantage is the convenience. So when you use the TRM, there are a lot fewer data requirements. You don't need to have the post-usage data, the weather data, or the comparison group data. It's a less complicated analysis. And what's really important is the timeliness. You don't have to wait close to a year after you install the measures to figure out how much energy you saved. And because of that, that can help a lot with planning and reporting. The disadvantages of using TRMs fall mostly into the accuracy. So when we look at measure installation rates, if it's a program where we're giving people power strips, what we found is a lot of them aren't installed. So you aren't going to get any savings from the power strip. If we look at measure retention rates, LEDs might be removed if people aren't satisfied with them. So you're not going to get the savings from the LEDs. We need to know what the pre-treatment usage was or the existing conditions in the home. So if we don't take account of pre-treatment usage, we're not going to have a good estimate of how much energy we expect to save. The measure effectiveness is also very important. We don't know what the quality with which those measures are going to be installed. For example, do the contractors do a comprehensive job of sealing all the leaks in the attic? The TRM might not be applied correctly. There might be interactions that are not taken account of, such as the shell, air sealing installation, and installation of a new heating system. New measures might not be included if you don't have information on what the formula is for those new measures. And you might have variation in your savings that just relate to your technical reference manual rather than to what was actually done in the program. TRMs are really important because they're used so frequently, and often people don't understand that these are not actually estimates of how much energy was saved, but rather projections. So TRMs are used frequently in regulatory reporting to justify program investments. As I said, we don't really know if the audience is understanding that this is not really how much energy you saved, and it's just a projection. And given that you're just projecting how much energy you are going to save, is this really an improvement over just looking at how many jobs you completed, how many measures you installed, or how many dollars you invested? Therefore, it's my opinion that there's an overemphasis on TRM as a measure of how much you accomplished in the program. TRMs are also used when calculating the non-energy impacts because they're an input into those calculations. They're used in cost effectiveness calculations, and therefore they can determine which measures are selected to be installed, whether the program is implemented, or whether the program continues to operate. They also are used in comparing one program to another. Energy efficiency resource standards require utilities to reduce their energy consumption by a certain amount over a specified period of time. And 27 states had energy efficiency resource standards in 2019. With these energy efficiency resource standards, TRM calculations are used to determine performance incentives and penalties for not reaching targets for savings. And TRMs are also used in decoupling to determine lost revenue calculations. Going back to that cost of 3 cents per kilowatt hour saved that I showed on the earlier slide, that estimate is based on a TRM. So when we're comparing the cost for energy efficiency to the cost for solar, we might be underestimating the cost for energy efficiency. However, if you remember that solar was 13 cents per kWh and energy efficiency was 3 cents per kWh, energy efficiency might still be significantly more cost effective. Here are a couple of examples of TRMs, and I'm going to focus on the first one. What this first table shows is how different your projected savings can be for the same measure installation just based on the TRMs, just based on the formulas that are being used. So if we compare floor insulation and how much energy we expect to save, the average annual savings per household using the Connecticut TRM is 150 kilowatt hours, and the average energy savings using the Illinois TRM is 58 kWh. So this shows you how those TRMs really result in big differences. And if you're ranking states based on these calculations, it really just depends on what formulas they're using. So we use a billing analysis to estimate how much energy was saved from a program whenever possible. The steps that we take are to get the energy usage data before and after measures were installed, get the program data that tell us when the measures were installed, what measures were installed. We weather normalize the data, we select a comparison group, and then we conduct analysis of subgroups of the total population. We do face challenges in the billing analysis in that because we need close to a full year of energy usage data before and after the measures were installed, we do have data attrition. And if it's too much, the savings might not represent the treated population. Sometimes we also have concerns about the sample size, depending upon how large the program is. If the sample size is too small, that can lead to low precision for the savings estimates, and we might not be able to conduct the subgroup analysis. Measure savings require an even larger sample size, as well as variation in the measures that are installed and significant installation of the measures that you want to look at. These are the data requirements for conducting the billing analysis. So with respect to the core data, we need the energy billing data. We need to know the service delivery date to divide the period into the pre and the post treatment. And we need the weather data to do the weather normalization. If we have supplemental data, we can develop more information about the program savings, such as measure-specific impacts. We can look at the different contractors and see if different contractors are achieving different levels of savings. And we can look at how savings vary by the housing unit characteristics and the household characteristics. For example, owners or renters, single-family homes versus multifamily homes. We use two different methods to weather normalize. We can use the household level method or the pooled. In the household level method, we look at each individual household and we weather normalize their pre-usage, post-usage, and look at the change for each household. The advantages of doing it at the household level is that we can remove the outliers. So we know that the savings that we're measuring won't be influenced by a couple of outliers, which may be caused by errors in the utility data. We can do a detailed attrition analysis and understand where and why we're losing participants from our final analysis group. And we can do a detailed analysis to understand why we're getting the level of savings that we're getting. With the pooled analysis, we analyze the usage change for all of the households within one model. And then the model estimates the average energy savings for all of the homes together. The advantages of this approach is that it uses all of the data that you have for all of the homes. So it doesn't only include the homes that have enough pre and post usage data. It doesn't require a full year of pre and post data. It provides a direct estimate of the impact. And within the fixed effects model, you can control for exogenous factors. Here's a little bit more information on the different methods that we use. So as I mentioned, with the household level analysis, we do a regression analysis on each individual home in the pre-period and in the post-period to look at the relationship between average daily usage and the heating degree days. And then we compute the normalized annual usage using the long-term heating degree days. In the pooled analysis, we run one fixed effects regression, which controls for the heating degree days and whether you're in the post period. And the result of this regression is the average daily baseload savings and also the heating usage savings per heating degree day. This is if you're looking at natural gas savings. When we're looking at electric savings, in addition to looking at the heating savings, we also look at the cooling savings and we control for the cooling degree days. So we want to use the house by house analysis when we have sufficient usage data for a significant percentage of the treatment and the comparison group. And we have data to assess the factors that are related to the savings. We want to use the pooled analysis when we have limited usage data availability. We're concerned about the attrition bias, and we don't have the supplemental data available to do the post subgroup analysis. Comparison groups are a really important part of the analysis to control for exogenous factors, such as changes in energy prices. For example, if energy prices rise in the post-treatment period, your participants might be reducing the amount of energy that they use, not because of the program treatments, but because energy has gotten more expensive. This is the perfect year to talk about using a comparison group because of the pandemic. We know that people are home more, they're working from home, and we've heard all the anecdotal stories about how people are using a lot more energy. So if we're looking at people who were treated before the pandemic and the post-treatment year is during the pandemic, we're going to see an increase in energy usage due to the pandemic, which is going to make the program look less effective than it otherwise would be. That's why it's important to use the comparison group, because the comparison group is also going to have that increase in usage. One of the ways of developing a comparison group, or in this case, it's usually called a control group, is random assignment. And some people refer to that as the gold standard. That's what they do in the medical field when they have a placebo group and an active treatment group, and then they look at the difference between the two groups. The difference when we're looking at an energy efficiency program is if you assign people to a treatment group and a comparison group that doesn't get the services, only part of the treatment group is actually going to move forward and take advantage of the services. And you don't know which part of the comparison group would have taken advantage of the services if they were offered them. Random assignment is also very difficult to apply in the types of programs that we look at. Often these energy efficiency programs are having a challenge finding enough participants. They have a goal for participation and for energy savings, and they're trying to bring in everyone that they can recruit to participate in the program. So the programs are not willing to withhold treatment. They're also not willing to withhold treatment sometimes because they want to serve those participants who are most in need. So in our evaluations, we usually use a quasi-experimental approach, which is our best alternative. And as the comparison group, we use later program participants, low-income non-participants, or a sample that's matched based on usage and other factors. This table outlines the difference in differences analysis using the later participant comparison group. So if we look at the treatment group, the change that we're measuring is both the program impact and other factors. If we look at the comparison group, the change that we measure is other factors. Because for the comparison group, we're looking at 2 years before program participation and 1 year before program participation. It's the same point in time, but they have not yet received program services. Therefore, their change in usage is only due to the other factors. So when we take the difference in the change between the treatment group and the comparison group, we subtract out those other factors. And what that leaves us with is what we're trying to measure, which is the program impact. Here's another more visual representation of what we're doing. You can see for the treatment group, this top, that here is where they receive their weatherization or their energy efficiency services. And we're looking at 12 months before and 12 months after, and the gross energy savings is A minus B. Now for the comparison group, we're looking at the same period in time, but instead of having the weatherization here between their two periods that we're looking at, we have the weatherization here after their two periods. So for the comparison group, their savings is C minus D. And we get the net savings by subtracting the change for the comparison group from the change for the treatment group. We also want to do subgroup analysis when we do this to answer other research questions, such as why are the savings higher or lower than expected? Which measures are providing the savings? Which contractors are most effective? How do savings relate to pre-treatment usage? And are certain types of homes providing higher savings? The key factors that we look at are which measures were installed, the cost of the measures, the pre-treatment usage, the contractor doing the work, and the home type. And the major measures are those measures that result in the greatest savings. And these, for electric, these include air sealing, insulation, duct sealing, heating system replacement, air conditioning replacement, and refrigerator replacement. Here's an example of a subgroup analysis. So this is for a high efficiency furnace and boiler replacement program. And here we look separately both at furnaces and boilers, and we also look separately at efficiency levels. So one thing that we see is that the boilers provide higher savings than the furnaces. The other thing that we see is that for the boilers, higher efficiency boilers result in higher savings. But for the furnaces, we don't see that linear relationship. Next, we want to look at the measure-specific impacts. And the way that we do this is we run a regression of the measures on the change in usage. And here's one example of measure impacts from a low-income energy efficiency program. Here we see that for insulation, we get 39 CCFs of saving for each $1,000 spent on insulation. And we get 34 CCFs of saving from the installation of a programmable thermostat. What this tells you is that the insulation is not really giving you the level of savings that you would expect. Here's another example of measure level impacts. This is from Philadelphia Gas Works Low-Income Usage Reduction Program. And for example, here you can see that a heating system replacement results in energy savings, average energy savings of 284 CCF. The other thing that we show in this table is the projected savings. And what you can see here is that for most of the measures that we look at, the projected savings are significantly higher than the savings that we estimate using our billing analysis. So the realization rates are, for the most part, below 100%. The next thing that we look at is cost effectiveness. So we want to determine whether the program as a whole is cost effective and whether specific measures are cost effective. And we look over the total measure life. So we use a discount rate to bring it back to the present value. In energy analysis, there are several different types of cost effectiveness tests that are used, and these vary with respect to which costs and which benefits are included. So the costs might include the program costs, the participant costs, or the ratepayer costs. And the benefits might only include the utility avoided supply costs and the participant savings, or they may also include the non-energy benefits. And here's an example of a cost effectiveness analysis from a low-income energy efficiency program. What we're looking at here is over different measure life assumptions, how much does it cost to save a kilowatt hour or a CCF of gas? So if we look at the electric baseload, we see that if we assume a 15-year measure life, it costs 5 cents to save 1 kilowatt hour of energy. And that is significantly less than the typical retail rate for a kilowatt hour, which might be 10 to 12 cents. However, if we look at gas heating, the cost to save a CCF is $2.10. And given that the cost of a CCF is $1, $1.15, this is significantly more than the retail price of a CCF of gas. I talked a little bit before about realization rates. And realization rates is when we compare the energy savings that we get from our billing analysis to the projected savings that I talked about earlier through the TRM, the Technical Reference Manual, or the engineering estimates. So we really want to understand this to understand whether certain measures are underperforming and if the TRM formulas should be adjusted. We can look at the realization rates at the customer level, where we look at the realization rate for each individual customer and then take an average of that. Or we can look at it at the program level, where we look at the total of the energy savings divided by the total of the projected savings. If we find that those realization rates are very different from 100%, we want to think about how the TRMs, how the formulas should be adjusted to improve the realization rates, because we want to have a better prediction of how much energy we're going to save. And there are several different parameters that can be adjusted. For example, the pre-treatment energy usage or the installation quality. Here's an example of where we look at the realization rate, and this is for a residential high efficiency furnace replacement program. So the Technical Reference Manual projected 17% savings, 17% of pre-treatment energy usage would be saved from the installation of furnaces, and 16% of pre-treatment energy usage would be saved from the installation of a boiler. Now, our billing analysis was not that far off. The billing analysis estimated 13% savings for furnaces and 17% savings for boilers. However, our realization rates are very low. We're only achieving 48% of the expected savings for furnaces and 62% of the expected savings in terms of energy for boilers. So why would that be? If our percent savings are fairly close, why would our realization rates be so far off? Well, the reason is that the formulas that were used had incorrect assumptions of how much energy was being used in these homes. So for furnaces, the Technical Reference Manual assumed that the average home was using 1,376 CCF. But when we did the billing analysis, we found that the average home was only using 862 CCF of natural gas prior to having those measures installed. So we have those much closer to 100%. Next, I'm going to talk a little bit about participant surveys. And participant surveys are also can be an important part of the research that we do. Participant surveys can provide us insights into why customers decide to participate in the program, what are the barriers to participating, how the program influences how the customers use energy in the home, and some of the other impacts of the program, such as home comfort and health, as well as how satisfied the participants are with the program. It's really important that certain procedures are followed to make sure that you get representative results from the surveys. So first, when you select the sample, you want to make sure that you understand who is represented. You want to stratify to ensure that subgroups of the population are adequately represented. What's really important is getting a high enough response rate so that you feel that the survey respondents represent the full population that you're looking at. So what we do is we send advance letters that explain the purpose of the survey. In addition to providing outgoing calls, we also provide the option for participants to call in. And in addition to calling, we've recently also provided the option for the survey to be completed online. Another thing that we found is if we provide an incentive with the advance letter, that increases the response rate. So for example, just putting a $5 bill in the advance letter really encourages the people who receive the advance letters to complete the survey. Other things that we do to increase the response rates are to make calls during the day, evening, and weekends. We leave a message every few calls. We do at least 12 calls, and we try to extend the survey period over at least 3 weeks. And what we find is that when we do this, when we're looking at program participants, we get survey response rates of at least 50%. And that compares to a lot of other surveys that we see done in the field where the response rates might be 10% or even only 5%. After you finish the survey, it's important also to wait for the selection and the response so that the population that you're looking for does represent the population of people who participated in the program. It's also important to report the response rates that are achieved. Here are a couple of examples of surveys and how they help. So in our 2016 South Jersey Gas Home Performance Program evaluation, we asked people why they decided to participate and install the equipment. And you can see that the most important reasons were that they had old equipment and they wanted to reduce their energy bills. And this can be important to help the program managers in determining how to market the program. We also asked about satisfaction with different aspects of the program. And we can see that overall 88% were very satisfied with the program. There was a little bit of a lower satisfaction rate with the contractor. Another important research activity is to do on-site observations and inspections. And for this, we either go on site and be in the field while the services are being performed, or we go in after and do inspection of completed jobs. And what's really important with these on-site observations is to make sure that we're not overemphasizing 1 or 2 visits. What happens sometimes with this work is there's over-reliance on anecdotal information. So what we try to do is to really do it in a quantitative manner where we have checklists and rating scales. We have training so that the experts are implementing the procedures consistently and that we quantify the findings. And here's one example when we did the National Weatherization Assistance Program evaluation where we had checklists. And for example, if we go all the way to the bottom and we look at used blower door while inspecting for leaks. So this relates to air sealing. And there were 96 observations done that were applicable to this question. And this action was only taken in 67% of the jobs that were seen. So this shows that there's room for improvement in terms of how that inspection is being done. Here's another example where we rate the quality of the work, and this is the attic insulation quality. We have many different factors that the inspectors are looking at to assess the quality of the work, and then all of these factors are added up to get to a mean rating. And one more example from New Jersey Comfort Partners, we found when we were looking at insulation quality that 52% of the 364 measures that were rated had a missed opportunity. So that means that they weren't installing the insulation in all of the places that they should have been doing this. I want to talk a little bit about what we've learned over time in terms of how to achieve high savings. And there are 3 main factors that we look at. One is targeting high users. So if you want to save energy, you have to target the homes that have opportunities to save energy. What we see on this slide is across different programs, if we look at the programs that have higher average pre-treatment energy usage, those programs achieve higher average energy savings. We see the same thing when we look within a program. For example, on the bottom right, we're looking at New Jersey Natural Gas's Home Performance with Energy Star program. And if we look at those homes that prior to services were using annually more than 1,200 therms, they had the greatest savings, averaging an annual amount of 329 therms. The next factor we want to look at is installing major measures. If you want to get higher energy savings, you need to install these major measures that we talked about before. And here's an example from New Jersey Comfort Partners, where we see that those homes that had 5 to 6 major measures installed saved an average of 218 CCF. And that's much greater than all of the other homes that were served in the other measure categories. The problem is that these homes that had the most major measures installed only represent a small percentage of all the homes that were treated. And the last factor is ensuring quality work. And that's where those on-site observations and inspections come into play to make sure that the work is being done in a high quality manner. And the way that we know that there's differences in the quality of the work that's done is that there's great variation in the amount of savings that you get across different contractors. Last is performance measurement. And the idea of this is really to make sure that you're looking at your program over time, you're refining it, you're piloting changes, and you're evaluating it again. One of the challenges, as I talked about before, is if you're doing a billing analysis, you don't get those savings estimates until 1 year after energy usage. However, when we talk about these other factors that influence energy savings, we don't have to wait a year to look at what's the energy usage of the people that we're treating. If you're treating higher usage households, you're probably going to be getting higher savings. We also don't have to wait a year to understand how many major measures we're installing per home. If you increase the number of major measures per home, you also are likely to be able to get greater savings. So what we find is it's really challenging to meet the savings expectations. But if we do these 3 things, target high users, ensure that major measures are installed, and maximize the use of proven home performance techniques, we see that greater energy savings are achieved. Last, I want to talk a little bit about non-energy impacts. And these are those other impacts other than energy savings. For example, a societal benefit is reduced emissions. A ratepayer benefit is if we have a low-income program and we're reducing energy usage, we can improve the affordability for the participants, and that might reduce collections costs. And another benefit for the participant is that air sealing can increase comfort. However, there are a lot of challenges in the non-energy impact literature, and this results with the expense and the difficulty in estimating these non-energy impacts. And because of that, often that's what's done is to review past studies, select particular benefits for inclusion, and then take the average of those past studies. But there can be a lot of problems with those past studies in terms of how applicable they are to the program you're looking at, as well as the methodology that's being used. And this is an example of 2 non-energy impact estimates from the same survey. The bottom line is, using the same survey results, these 2 estimates got very different results. One estimated the monetary value of the non-energy impacts at $43, and the other estimated the energy value of the non-energy impacts of $1,439. And that's because there were a lot of differences in the way these surveys were analyzed. One used the same participants in pre and post periods, one used unmatched samples. One used our differences in differences estimate that I talked about earlier, and one used a different comparison. One used only those estimates that had at least a 90% confidence level, and one had no requirement for a statistical significance. And one used only data from the reference survey, while the other one brought in external data when the survey did not find a large non-energy impact. So our recommendations for non-energy impacts is to carefully review the studies that are referenced, to really make sure that you understand the methodologies and the limitations, and to assess how applicable those other studies are to the program that's being evaluated. I want to conclude with just a few recommendations. With respect to energy efficiency, again, treat the high users, install major measures, and provide training and quality control. With respect to evaluation, estimate savings using billing data, weather normalize the energy usage data, use a comparison group, and reassess frequently. And when reviewing a study, really pay attention to the sample that's used, your attrition or your response rate, what the methodology is. And we also think that it's really important that there's a separation between implementation, evaluation, and advocacy. And last, make sure that you really understand those methodology issues and how the research is being addressed, rather than just accepting the savings and the findings as they're presented. So that's my presentation, and I look forward to hearing what questions you have.
I think there were some questions in the chat, and Mike, if you want to start off, you sent me a question that maybe you want to ask Jackie.
Sure. So, and I understand why we use it, but why limit the sort of analysis to cost effectiveness? Well, you know, in solar programs, we're not limiting it to, you know, just cost effectiveness in the overall program. I know why we use it. We want to prove to the rate council and others, you know, it's within the cost curves that we have. But in the analysis, why limit us to just cost effectiveness?
What do you mean by limiting us? Do you mean only including programs that are cost effective?
Right, correct.
Well, that's the regulator's decision, really. And, you know, we're just providing the information. And there's often this argument that we should not be providing these services unless they're cost effective, whichever way you tend to measure them. And, you know, one of the ways that, you know, some people argue it shouldn't be cost effective just based on how much energy you save. So, right. For example, we want to take into account the environmental impact. What's the impact on emissions? What's the impact on the economy? What's the impact on the health and safety of people who are participating? And that's a way that you can bring in other factors.
So those non-energy benefits get more important, right?
Right. And
so that we weigh them more than just the dollars saved. We have different decisions in the program than just the cost. And that was my question. I knew what the answer was, but I wanted to ask the question.
Right, right. So there is a very strong argument that these non-energy benefits should be included in the cost effectiveness testing. And the challenge is that there's a lot of disagreement about how they should be measured and what's realistic. And there's some people that argue, oh, the non-energy benefits are way higher than even the energy benefits that we get. And then there's some people that argue that, you know, a lot of these non-energy benefits are overstated. And my view is that we really need to do a very careful way of calculating what those non-energy benefits are and to be able to justify them. And then you can get acceptance for including some of those non-energy benefits in your cost benefit analysis.
Last question, what did you think of EPA's sort of their other benefits analysis that they went through?
I'm sorry, I don't know the details of that enough to comment on it.
All right, thanks. Great to see you again.
Thank you. Okay, I see a question here. Have any public utility commissions done a particularly good job of quantifying and assigning value to non-energy benefits such as public health to utility or state energy efficiency programs. One place where they've done a lot of work on non-energy benefits is in California, especially on their low-income energy efficiency programs. And that's one jurisdiction where they've been including their non-energy benefits in their cost effectiveness testing for many years.
Tim Fagan wrote, when do billing analysis on homes with multiple measures installed, when doing, billing analysis on homes with multiple measures installed, how do you distinguish which measures may be falling short on ex ante savings level if billing analysis shows a shortfall?
Well, what you can do is you can, after you determine the energy savings for the program as a whole, you can do that regression analysis where you regress energy savings on the individual measures that were installed. And then you can get estimates of the measure-specific energy savings and look at those compared to what you expected those savings to be.
Anybody else have a question to ask?
I see, do you conduct aspects of the survey in languages other than English? And the answer is yes, we do. We have staff here at APPRISE that are fluent in Spanish, so we'll often be conducting surveys in Spanish. And for one recent evaluation that we did in New York City, we even found somebody at Princeton University who spoke Mandarin, and we brought her in and she conducted those interviews.
Matt, go ahead.
Hi there. This was probably the best presentation I've ever heard on this topic. So thanks.
Thank you.
But I want to bring in a different perspective of urgency and how that leads to looking at this a little bit differently. You know, what if, as I suspect, we're really going to have to ratchet up our ambition and our performance, specifically in this area, because this area is so critical. But I think we need to think outside the box in a lot of ways without losing sight of what you've shown us, including a lot more use of social science to study why do people resist these things? You know, the people element, how do we overcome that? And there's all sorts of ideas out there on that. Then the one thing that I think some people don't want to talk about, the Jevons paradox, you know, the blowback phenomena. Is it real or is it false? I've read both things, but it's really important to resolve that, because we don't want to do all this and find that at the end of the day, it's backfiring on us. So it's just some things for you guys to think about.
I agree. I think that programs are trying to be more creative in terms of bringing people in to participate, and there are different challenges. In the low-income program, those are usually completely free. So you need to try to build up trust and make people understand that this really is a benefit. It's not a scam. We're going to come into your home and do $5,000 worth of work for free, and it's going to provide you with these benefits. In the market-based programs, people will receive incentives, but they have to take the time to understand it, understand the benefits, and be willing to participate. And it can be challenging. It can be challenging. In those programs where it's on the customer to do it, there are a lot of things to figure out and to understand. And having just installed high efficiency furnace in my home and air conditioning, I know what that entails.
Great. Well, we're at the 2 o'clock mark. I have to go teach, but I don't know if, so I think we're going to wrap up. Maybe one more question if somebody has one last question. Can't tell if, well, if not, thank you so much. That was actually a really helpful presentation. I might be writing you on some of the research I'm doing. So that was very useful. And I think a lot of people got a lot out of it. So thank you, Jackie, for for your time, and hopefully we'll get to engage with you more.
Thank you so much. And if anybody else has any other questions, please feel free to be in touch with me. And if you have any students who are interested in doing this type of work, please send them my way.
Great. Thanks so much.
Thank you.